Hello viewer, I am Sumit Basu. Today in this video I like to introduce you the differentiation of class 12 where the chain rule is applied. Chain rule is very important. So this is sum number 1 that yk equal to tan inverse root over a minus x by a plus x. Find dy dx using a suitable substitution. So you must be aware of the substitution. Very carefully follow the sum. Let see tan inverse root over a minus x by a plus x. This is not the standard form. So in order to make it a standard form, we must assume or substitute so that it will convert into standard form of differentiation. So y become tan inverse So let's write down the sum. So x equal to a cos 2t to theta. And in the denominator it becomes a plus a cos 2 theta. Be careful about the substitutions. So substitution is very important. You must follow it very carefully and practice it. So it is special trigonometric substitution. So a will go out. Now what is remaining? So tan inverse 1 minus cos 2 theta minus cos 2 theta by but 1 minus cos 2 theta equal to, you learned in the multiple angle, equal to 2 sin square theta, and 1 plus cos 2 theta is equal to 2 cos square theta. I am writing in the bracket. We know cos 2x equal to, from the multiple angle learned in class 11, 2 cos square x minus 1. So from this follow 1 plus cos 2x is equal to 2 sin square 2 cos square, and also cos 2x is equal to one minus 2 sin square x. So you should remember this formula, very useful formula for doing differentiation. So for multiple angle, very vital formula, must keep in mind, and it is very useful. So let's see the steps next. So tan inverse root over tan square theta, because sin square theta by cos square theta equal to tan square theta. So tan inverse tan theta is equal to only theta, because we know tan inverse tan theta equal to theta. In the trigonometric, I will write down the step by step in the following line better. So it is tan inverse tan theta tan inverse tan theta is equal to, chain rule is very essential and very important. See other video, previous video from video number 6 to 12. I will also upload other video and many others on differentiation from video 6. Anyway, now let us see. So tan inverse tan theta equal to theta, and now x is equal to a cos 2 theta, and therefore 2 theta equal to cos inverse x by a. Therefore theta equal to, you will have to show this in the examination to carry full marks. Okay, so do not write down theta mentally or directly. You have to show the steps. Now let's see. So it becomes half cos inverse. Again x by a is not a standard form. Cos inverse x is a standard form, but there is a x. So let's see how to do. Now differentiating with respect to x, dw dx. So dy by dx equal to, half is outside constant, it comes out and is kept outside, and dx of cos inverse x by a. Now x by a, already I have told, is not a standard form. So be careful about the chain rule here. The chain, always chain rule is used. So ddu of cos inverse v, let v, and dd x of x by a. Now cos inverse v is standard form, so equal to 1 by minus root over 1 minus v square, and ddx of x by a equal to 1 by a is constant, it comes out, and ddx of x equal to 1, so it is written down. Now let's see very carefully. Now dy by dx is equal to, be careful always, so half by putting the value of v, x square by s square. I am showing the detail because you should do also, but at the faster rate you should do. Actually I am showing you for all students or the viewers, so that they can follow this. So to let these steps, be careful, taking LCM and then a square, then 1 by a, then is equal to minus half as usual. So this is in the denominator 1 by a, square root of 1 by a square equal to 1 by a, and in the radical sign, a square minus x square is left behind. So 1 by a are cancelled, therefore minus half and arranging this actually. 2 outside is 2, so and 2 is there. So I hope this is the answer. So chain rule, and these all steps are very important for all of the students or the learner must practice this very carefully. Very much essential. So adopt the chain rule. Next sum. dy by dx equal to y equal to tan inverse 4 root x by 1 minus 4. Very useful sum and very important sum, and you can understand this sum, follow very carefully. Very important sum because using a suitable substitution you have to do. So if you practice it, you can do it because you have to guess seeing the format of the sum 4 root x by 1 minus 4x. So okay, to do so the best substitution in this case is x equal to 1 by 4 tan square theta. So putting the value in the place of x, see 4 into so 4 gun, so half gun, 2 and half, so tan theta in the denominator 1 minus tan square theta. So 2 tan theta by 1 minus tan square theta. So you know 2 tan theta by 1 minus tan square theta is equal to tan 2 theta from the multiple angle learned in class 11. Tan 2 theta equal to 2 tan theta by 1 minus tan square theta. All the multiple angles and some multiple angles, the formula are very essential. Keep it in mind. Tactfully remember all these formulas so that calculus will be in your hand. The trigonometric formula, especially multiple and some multiple angles from all corners. Practice and remember it. 60 to 70% of the sum will be in your hand. Unless you know the formula, I think it will be not possible to do the sum. Now 2 theta. Now theta equal to in the bracket tan inverse 2 root x. See, x equal to 1 by 4 tan square theta. So tan square theta equal to 4x. Tan theta equal to 2 root x. Okay, you have to show this as I did in the previous sum also, and how the theta is obtained in terms of inverse. So you have to show this step in the examinations. You do not use or write down directly the tan inverse 2 root x. You have to show this clearly, otherwise marks will be deducted in the board exams. And also it is difficult and confusing, there is a chance of wrong. Okay, so better to work out the steps getting to get theta. Okay, now differentiating with respect to x. See again, that is tan inverse 2 root x. So tan inverse 2 root x is also no standard form. That is why for 2 root x we substitute something, and we substitute v. Then tan inverse v is a standard form. So whenever the sum is not in its original format, not in the standard form, not when the sum is not amenable to its standard form or not it generally consistent with the standard formula, then you have to substitute so that the sum must be inconsistent with the standard formula, so that you can differentiate it very easily. See also the others video, step by step you can understand. Many sums have been worked out for all. Now see the sum. So tan inverse v equal to 1 plus b square, because tan inverse x is standard form. Okay, and 2 is constant or come out, and differentiation of root x is 1 by 2 root x. See, remember this. It is very much helpful in doing the sum. Directly you can put that differentiation of root x equal to 1 by 2 root x. You can work out yourself in your home. I perhaps done this in the bracket. ddx of root x c. Okay. So you can see how it is done, x to the power n format. So how? Okay. Now putting the value step by step. So 2 cancel. So answer is follow. So substitution. So x is equal to 1 by 4 tan square theta. This substitution, how you can guess it? It is just mere practice. More you practice, you can do. I think you can do this sum. Practice all these step sums you can do. Now come to the next sum. This is again a sum relating to substitutions. It is though a common format, because 1 plus x square tan in y equal to tan inverse 1 plus x square. So whenever there is 1 plus x square under root, always assume x equal to tan theta. Okay, so that it will become a very easy. It becomes a standard form. So now putting the value 1 plus tan square theta, x is equal to tan theta is assumed, and minus 1, so tan theta. Now 1 plus tan square theta equal to sec square theta, root over sec square theta equal to sec theta is written. So sec theta minus 1. Okay, so root over, so sec theta minus 1 by tan theta, because sec square theta equal to 1 plus tan square theta. You learned in from class 10, 9 perhaps, or 10th or must. So tan inverse. So now breaking the sum in terms of sin cos format. So sec theta equal to 1 by cos theta. You can easily understand this sum. So so cos theta gone. So from the sum multiple angle we have used this formula. Now let's see the next step. So tan inverse 1 minus cos theta by sin theta. Till this we have done. Now we proceed for the next step. Follow this very carefully, though not a difficult sum, but you must be very careful in doing this sum. Now see the entire part. So Okay, so let's do the 2 sin square theta 1 sin square theta by 2. So from the sum multiple angle we have borrowed it. So sin theta by 2 cos theta by tan theta by 2. So tan inverse tan x equal to, you all know that x, so tan inverse tan theta by 2 equal to theta by 2, so half, but theta equal to tan inverse x. We have to show this very carefully. We have to show the step. Now differentiating the sum dy by dx equal to half ddx of tan inverse x. So ddx of tan inverse x equal to 1 plus x squared. So this is actually y, then dy by dx is equal to 2 is outside, so 1 plus x squared. This is the answer. Hope you have followed this sum. So important part to say here is the multiple angle and the sum multiple angle. All the formula you must remember. Thank you very much.